So percentages are a part of our everyday life, and one good way to illustrate percentages and to illustrate how important they are to us is to think about interest rates and in particular compound interest. So I have a problem for you. Imagine you were given $20,000 and you invested it at 3%, or you were given $10,000 and you invested it for 7% and you left that money in the bank for 20 years. Which outcome would be the best for you? So I'm going to go through a little exercise now to show you, one, how to work out or calculate percentages, and secondly, why it's relevant. So here's a little percentage problem that's relevant to each and every one of your learners. So we have a situation here where we've got $20,000 invested in the bank for 20 years at 3%. And over here, we've got half that amount, $10,000, invested also for 20 years at 7% compound interest. So how do we calculate interest? It's pretty straightforward. Most of you will have phones, and you have a calculator function on your phones. You put in the 20,000, in this case the $20,000 amount, and to increase that by 3%, which is what you're doing here, you just multiply by 1.03. And the answer is 20,600. So after 1 year, our sum has gone to $20,600. That's after 1 year. 1 year on, now most calculators you've just got to push equals again, and that will multiply it again by that amount. And we know after 2 years, that's gone up to $21,218. $21,218. The important thing, by the way, about compound interest is that you get interest on the interest. That's important both when you're accumulating money, but it's also when you have debts. So your debts accumulate interest on their interest. That's what compound interest means. So the next one, the next following year, in 2020, our sum has gone up to So there we are. After 20 years, our sum of $20,000 has increased to $36,122. Now this is an exercise that you could get students to do very easily in class. It would be a good idea to set up the template with the years down the side and the starting amount. It's a very simple exercise for them to do. So you're doing two things here. One, you are teaching them how to manage percentages, and secondly, you're educating them about the impact of compound interest. Now remember that when you're multiplying, to get a 3% increase, you multiply by 1.03. If you now the other side, we've got half the amount of money, but at 7% interest, and this time, after 1 year, our 10% has gone to, multiplied this time by 1.07 equals 10,700. After 2 years, 11,449. By the 19th year, we're at $38,696, and by 1 year later, we're up to $41,405. So, in 20 years, we went from 20,000 to 36. From here, we've got from 10,000 to 38,000, or in the following year, $41,000, illustrating the impact of compound interest. Now, this works two ways for your students. One, this is a great way to think about accumulating money. What will be more relevant to them is the way that debt builds up on them. So if they, for example, borrowed $1,000 on their Visa card, the interest rates for that are anywhere between 15 and 21%. It would be very easy to calculate how their debt grows, not their accumulated nest egg, but how their debt grows by compound interest. So in the same way here that the interest compounds and we get interest on interest, if we're doing it with the debt compounds, and so we get debt compounding on more debt to build up a bigger debt, and it with a very short period of time you could have to pay back twice the amount of money that you originally took out by way of the loan if you're getting a loan from either your Visa account or from even from a regular bank without security, or if you're paying off something at a shop like a local hardware store or a place that offers in-store finance. The interest rates are usually between 15 and 25%, so you'll pay back a lot more money. And if you get students to do this themselves, it becomes visible to them because they're handling real data.